Hi everyone and welcome to another video for Agricultural Engineering 311. Today is going to be a lecture about management and managing your irrigation, and we're just going to look at specifically water and managing the water. So after that we're going to do some calculations, and we're just going to look at the calculations roughly today, and then from tomorrow we will start spending a bit more time with these calculations so that you can get used to doing them. So management and managing irrigation is firstly water application. So it's important to know how many millimeters of water is applied with an irrigation system, and that refers to when you are using or putting on your irrigation for a certain amount of time. It's important to know how much water, so the volume of water that's being applied, and secondly, especially if you're looking at all your emitters, making sure that all your emitters are delivering the same amount of water, because that's also a way of just finding places in your irrigation where you might be experiencing problems. So if you want to measure your water that you are giving at a specific time, then there are two ways: flow measurement or measuring of emitter delivery. So flow measurement is you install a flow meter on the main line to measure the water. So it's a physical meter that you actually put on the main line, and you can calculate or measure the amount of the volume of water that you are delivering, and you can take the area and then you can calculate the gross application per month. So how many millimeters depth wise are you giving per month to your crops with a certain volume under a certain amount of area. Then the next is measuring emitter delivery. It's another way of measuring the amount of water that you are physically giving the crops or giving a specific piece of land. So as you will remember from that first couple of slides, we had your laterals and then you had your main line. So to test this emitter delivery, you're going to take 5 laterals and you're going to select 5 emitters per lateral. So that's 25 emitters in total. And then you're going to measure for this 25 emitters. You're going to measure, maybe you put it on for 10 minutes, and then you'll measure the volume of water that's being delivered from an emitter in that 10 minutes, and that's how you know how much one emitter is giving your crops. So after you've taken the values that you are getting from measuring emitter delivery, you'll start noticing that sometimes there's a big difference between the emitter that gives the most amount of water as opposed to the emitter delivering the least amount of water. And so when that deviation between the emitter giving the most and the one giving the least, when that deviation gets to 10%, that's when you know that you should maybe change an emitter, or that you have a problem in your irrigation system. And this table specifically will look at that. So how do you calculate these different emitter deliveries, or the deviation is you'll have your 5 laterals and 5 emitters on one lateral, so it's 25 in total. And in this example, this is what they measured for those 25 emitters. And you can see that it ranges between a relative value, and after calculating all of them together, you divide it by 25 and then you get an average. So that's the average for 25 emitters, and that's usually the value that you use to calculate how much water you are giving for a specific block. Now when you want to start calculating how do you know some emitters are faulty or some are giving too much water, you will take your maximum delivery. So you look through this block and you find the one with the maximum value, and your minimum one. So you're looking through your whole block and you see there's the one that's giving the minimum amount. And then you take that maximum delivery, you minus your minimum delivery, and then you divide that by your average. And then if you multiply that by 100, then you will get your percentage. So for this example, your maximum was 252, your minimum was 2,04, so you took 2,52 minus 2,04 and you divided your answer by 2,25, and then you multiplied that by 100 to get it into a percentage value. And because the variation is 21,3%, you know that there is some emitters that needs to be replaced because it is more than 10%. So now that you know how much water is going out of your emitters, you can very accurately determine your standing time. So how long should a cycle be for you to be able to apply the correct amount of water. So firstly, you'll determine your available soil reservoir. And what that means is underneath your plant, if I can show a sketch like this, underneath your plant, you'll see that there is a lot of space and there's soil with a lot of air. So only the spaces filled by air is the available space for water to go into. And because we know we can't just take this whole value, we need to look at what part of that value does have space for water to go into, and our available soil reservoir is the wetted surface. So that is, if you've got a micro sprayer, then you will look at the radius that it's wetting, and you'll also look at the laterals in that radius, and you'll look at the total area, so the oppervlak that is being wetted, and you'll multiply that by the effective root depth. So to go back to this sketch, so firstly you calculated the wetted surface, that's that surface at the top, the root depth obviously being depth to get you to a 3D image, and you'll multiply that by the soil water capacity. So that's how much water you can apply. Next is the maximum gross application. So that's the value that you calculated in the previous one divided by the application of efficiency. So that is with, for example, a drip, that'll be 90%, or microsystem maybe 80%, 85%. So it's that value that you calculated there divided by the efficiency. Standing time required for gross application. So the maximum gross application is the available water reservoir. So the space you have, the maximum gross application, divided by the application rate of the system. So that is the liters per hour that your system is applying at the moment. And then your theoretical cycle length is the available water reservoir again at the top with your net irrigation requirements. So that is the amount of milliliters that your plant requires per day. And I think that is enough for this video. In the next one, we'll do one of these calculations. Thanks.